Welcome to clickmyproject.com. Modified FCM approach for MR brain image segmentation. Clustering can also be thought of as a form of data compression, where a large number of samples are converted into a small number of representative prototypes of clusters. High dimensional feature space based on image segmentation is time intensive than in one dimensional feature spaces. The modified FCM algorithm is based on the concept of data compression, where the dimensionality of the input is highly reduced. The data compression includes two steps: quantization and aggregation. The quantization of the feature space is performed by masking the lower m bits of the feature value. The quantized output will result in the common intensity values for more than one feature vector. In the process of aggregation, feature vectors which share common intensity values are grouped together. A representative feature vector is chosen from each group and they are given as input for the conventional FCM algorithm. Once the clustering is complete, the representative feature vector membership values are distributed identically to all members of the quantization level. Since the modified FCM algorithm uses a reduced dataset, the convergence rate is highly improved when compared to with the conventional FCM. This is the overall flow of our project. The input image is loaded and then filter is applied for the input image in the pre-processing block. Median filter is applied for the input image, and the denoised image is given as input to the feature extraction. And then the same step is followed for the training images. The both text image and training images, another input true labels are given to the input as the multi-swim classifier. Multi-swim classifier is used to classify the input image is either is normal or abnormal. If it is abnormal, means segmentation using modified FCM clustering, and then the segmented region is displayed as output. In the load image block, the input in this module we initially select the test image from the dataset. We select the different types of MRI brain abnormal images from the database. In pre-processing, the test image is pre-processed by using the median filter. The median filter is a non-linear digital filtering techniques often used to remove noise from the image. Such noise reduction is a typical pre-processing step to improve the results of data processing. Median filtering is very widely used in digital image processing because under certain conditions it preserves edges while removing noise. And then a modified FCM for segmentation. Clustering techniques can be seen as a data type compression technique. In this, dimensionality of the input image is reduced to a good extent. Here, huge number of input sample is converted to less number of representative clusters. FCM is the clustering technique that permits one pixel to belong to more than the one cluster. This algorithm divides collection of pixels into collection of clusters according to some criteria. The quantization of the feature vector is performed by masking the lower m bits of the feature value. The quantized output will result in the common intensity values for more than one feature vector. In the next step, grouping of feature vectors having the same intensity values is done. This process is called aggregation. One representative vector from each group is taken and given as input to fuzzy Siemens algorithm. Modified FCM uses reduced dataset convergence rate in improved as compared to normal FCM technique. This technique includes similar steps as FCM except for the variation in the cluster updation and the membership value updation criterion. For the classification, we use multi-swim classifier. The multi-classifier performance either the input image is normal or abnormal. If abnormal means we classify either it is benign or malignant category. The classifier we are used in is multi-SVM. Multi-SVM is a machine learning algorithm that is used to classify the input image is related to which class in a multi-class category. We train the multi-SVM using the test feature, train feature, and the true label. By learning the classifier, it classifies the input image depends on which class. In performance evaluation, lastly we calculate the performance evaluation of the classifier, and also we calculate the RAND index, global consistency error, mean square error, and pitch signal to noise ratio for both the FCM and the modified FCM algorithm. The simulation results show that the RAND index is maximum for modified FCM as approach as compared to FCM, and the GC is minimum for modified FCM. We also calculate the performance of classifier like sensitivity, specificity, and accuracy. Open the source code folder, select MRI main.m file, and then run. New GUI window will appear. Select the input image from the database. Select any one of the images from the database and apply this is the input image and it is a filtered image. Apply segmentation, modified FCM technique for the input image. This edit box shows the rand index for MFCM technique. The figure 9 shows the weight component versus the time for the modified FCM technique, and this shows the cluster index versus variance for the modified FCM technique, and it is a cluster unit versus segmented pixels for the modified FCM technique. This is the segmented output for the modified FCM. Figure 2 shows the fuzzy membership function of cluster partition and membership degree, and it shows the figure 3 shows the iteration versus cost function, and it is nothing but objective function. The segmented image is also displayed here in the axis 3, and this table displays the pixel label, pixel count, and the center values of the modified FCM technique for the input image. Cluster 1 has a high inter-cluster similarity. Rand index of the modified FCM is 66.4553, and global consistency error is 0.27, and the segmentation time of a modified FCM is 34 seconds. Now I apply the FCM technique for the same input image. The figure 13 shows the segmented output for the same input image by using the FCM technique, and this is grayscale segmented image, and it is a color mapped image. And figure 10 shows the fuzzy membership function for the FCM technique, and the rand index for the FCM is 58, and the global consistency for the FCM technique is 0.32, and segmentation time of the FCM technique is 170. From this I conclude that the modified FCM has a high rand index than the FCM technique and a low global consistency when compared to the normal FCM technique. It also has a modified FCM also has a less segmentation time. Thank you.